Okay, let me just start by saying this. When I got the email about this, I was surprised and pleased. The reason I was pleased is almost exactly 25 years ago, I was invited to a conference in Tehran. I don't know whether you know about this conference, philosophy conference in Tehran 25 years ago or 24 and a half years ago. Uh, in philosophy, and a number of my friends were invited. I didn't go because I my son was being born exactly during that time, and it was more important for me to be it's to stay in New York with my wife and my son being born. But my friends who went to Tehran had a wonderful time in visiting Iran and meeting philosophers in Tehran, and I have always liked Persian culture a great deal and know a little bit about it, and really regretted not going then. And so when I got this invitation, I thought, well, at least if I'll probably never get to go to Iran, but at least this way I will have some connection. I also just want to say at the very beginning that it's very unfortunate that the relationships between my country and Iran are not very good right now, and so it's not going to be possible for visits back and forth because I think, in fact, both cultures are important and great, and I wish things would get much better. Okay, so when I got the invitation, I realized that I did have a talk related to the conference that I could give because I'd been giving a talk related to similarly in various places. I've given this in India and I've given it in China and in England.
Hey, Barry,
Not exactly the
before you start, can I give you a brief introduction of you and what you've researched on for anybody who's maybe wants to get to know you and your
Oh,
academic
sure.
background?
Give my email and tell people if they find anything interesting that I say, they can email me later. Is what I said so far, was that audible, what I just said?
Yeah, your sound was loud and clear. All good.
Great. Okay. Okay. Go
Um,
ahead.
I'll explain it in Persian for our Persian listeners. دکتر
Sure.
برای لوئر استاد فلسفه دانشگاه راتگرز هستن و لطف کردن که از شهر نویک مزاحم ما در واقع تشریف فرما شدن. ایشون تو زمینهای فلسفه ذهن، فلسفه علم و ارتباطات ریاضی و فیزیک با فلسفه کار کردن و ارائه‌ای که امروز در خدمتشون هستیم در واقع فیزیک کوانتومی، مکانیک کوانتومی و ذهن هستش. And Barry, about the thing that you said, it was unfortunate that the relation between Iran and the U.S. is not good. We would love to have you in person, but even having you uh, in a online meeting, it's a pleasure for us and an honor. And right now, you can start. And thank you.
Okay. I just would mention you might find this fairly ridiculous, what I'm about to say, but I really love Iranian cooking, Persian cooking, and there's a very good Persian restaurant in New York where I live, and I will go have dinner there tonight. Uh,
Oh,
so
are you gonna have kebab? Are you gonna have like kubi there or like a korma sabzi?
I will have some kebab because I like
uh,
kebabs very much.
oh,
So,
lovely, lovely.
okay. And anyway, and if anybody comes ever can get to New York, you're welcome to visit me. I live in Manhattan and I teach at Rutgers University. Okay, so here's what I want to talk about. I'm a philosopher of physics mostly. I work on philosophy of quantum mechanics and on philosophy of statistical mechanics, but I'm also a philosopher of mind. And the idea that there's some relationship between quantum mechanics and issues about consciousness has been percolating around for a long time. Uh, can I ask you a question? How can I change my slides to
uh,
go from?
you have the control at the bottom of your screen. You can change the slides. So
How do I
you're
do that?
with we can do it with your mouse, and you can do it with your keypad, or
See if it
it's just
works.
switch if you hit
Doesn't
on the next.
doesn't seem to work.
Oh,
Well,
there is three small pointers on the top of the screen. Iran consciousness, new one, and 3 points. Okay.
3 points. So on my
Yeah.
screen,
Click on the 3 point and manage it. Okay.
there we go. I got it. Okay, good. Okay, so now I'm okay. So there are 3 questions that I'm interested in saying a little bit about. I won't be able to say that much about it in an hour. These are all complicated issues, but I'll at least give you a feeling for some of the thoughts that have been going around in my neighborhood at any rate, and I'm sure some of you have heard of some of these things before. So we'll talk about them a little bit. So one question is, how do brain processes give rise to consciousness? That's, of course, a deep and interesting question in biology and in philosophy as well. And another related question has to do with the relationship between what goes on in our brain and what we call free will. That's also a long, complicated question. I'll only touch on that a little bit. And then there's a question in the philosophy of physics or philosophy of quantum mechanics, and that there's a special problem about quantum mechanics, and that is how do quantum mechanical processes, especially measurements, result in determinate outcomes. And people who've investigated the quantum mechanical mind connection claim that these 3 questions are connected with each other. Now, in fact, when I've investigated this and thought about it, my conclusions are really negative. I think these issues are really not very much connected to each other, but they're interesting and they're interesting to think about. And so that's why I'm going to talk to you a bit about them. Okay, now I got to get to my next slide. Let's see if I can get to it. So the next slide I get to, here we go. Okay, so there have been many important thinkers who have talked about the relationship between the quantum mechanics and the mind. Here's a big list of them. Many of you have heard of these people, very famous physicists like Werner Heisenberg, the very famous and important mathematician, Johann von Neumann, Roger Penrose, Roger Eddington, Eugene Wigner, Eugene Pauly, Compton, Dyson, Wheeler, Stapp, some famous brain scientists like Eccles, some philosophers like Karl Popper, whom you've probably heard of, and David Chalmers. I don't know whether this has been discussed much in Persian philosophy. I just don't know enough, but I'd be interested to know whether any writers or authors in your tradition have talked about quantum mechanics and about the mind and their connection, or either of them separately. Also, there's an interesting book by a British judge named David Hodgkin about this subject. So these are some people you might want to look up if you keep my slides. You can look at these people's names. Okay, so let me make the next slide. Here's some pictures of them, so we don't have to tarry on them. Get next one. There we go. So why do all these smart people think that there is a connection between quantum mechanics and the mind? Well, the mind is mysterious. Everybody agrees with that there are mysterious things about the mind. How does free will arise? What is it really, and how does it arise? How does consciousness arise? Consciousness seems so different from physical phenomena. Are these connected to each other? Also, quantum mechanics is mysterious. And so the idea is maybe these 2 mysterious things are connected to each other. And the idea is that people have had is that quantum mechanics needs the mind in order to produce determinate outcomes. That's the main idea in the history of quantum mechanics. And it's an idea that has been proposed by many important thinkers in the history of quantum mechanics, including von Neumann and Wigner. And also the mind needs quantum mechanics to produce consciousness and to produce free will. So that's the idea that these two are going to be are connected with each other in some way. Okay, let's see. Did I skip a slide? Maybe. Let's see. Where are we here? This is working well enough. Anyway, okay. So I just wanted to start by reminding everybody of some physics, which most of you probably know. That in classical mechanics, the mechanics that was, the history goes way back to the to Greeks and Arabic writers in the Middle Ages, but was developed particularly by Newton in England and Descartes and Lagrange in France later. And the basic idea is that the fundamental stuff of the universe consists of particles, like what we would call atoms, and fields. And these have certain properties. Particles have masses, charges, maybe other properties, and fields like electromagnetic fields have electromagnetic field values. And the universe at a time consists of a lot of particles located in various distances from each other with their properties, moving at certain velocities, having momentum, and the fields are undulating. The field values are changing over time. In any region, there's the state of the particles and the field in that region. And we can describe the whole world by describing what the field is in any small region and what the particles are in any small region. This is called separability. And the evolution of the state of the world is deterministic. That means that there's a fundamental dynamical laws which say how the state of the universe evolves over time. In classical mechanics, the law is very simple. Everybody learns it in high school or college. They learn the laws F equals ma, that the force on a particle says how that particle changes its velocity over time. It's a little differential equation that describes that. It's very, very simple. One of the things that strikes me is how astonishing it is that our universe can be described by such simple, simple laws. Whenever I think about this, I just sort of feel awe. I'm struck with awe. However, deterministic classical mechanics isn't exactly right. Oops, here we go here. We'll come to why it's wrong in just a minute. But one of the worries that many philosophers in the Western tradition, at any rate, and probably elsewhere, had, is that when you look at classical mechanics and you look at what it says the fundamental ontology of the world is, there just doesn't seem any room for the mind in this account. In fact, Descartes, the French philosopher who got a lot of this stuff going in the 17th century, he actually said, well, the the material physical world isn't complete. In addition, there are mental entities, souls or minds in the world. Uh, but as physics developed, it was hard to figure out how these minds could fit into the world. And that's because physics was in a way complete. Every physical change could be accounted for by a physical previous state. And so the mind looked like it didn't have anything to do. So most Western philosophers, at any rate, have gotten to view the idea that if there are minds, which of course everybody thinks there are minds, I think I have a mind, I think you have a mind, minds must in some way be physical. They must be part of the physical world. But the question is how? How is that? How can we understand minds as being part of the physical world? That's the big, most fundamental, difficult problem, I think, in philosophy now. How to understand how it is that our minds, consciousness, beliefs, intentionality, our will, how it fits in to the physical world. It must have to do with our brain in some way. My colleague and friend Dave Chalmers, who some of you may have heard of is wrote a big book about this, about mind, and Dave Chalmers calls this the hard problem of consciousness. How is it that things going on in your brain give rise to our conscious experiences, our feeling of the sun? Right now, the sun is just rising in New York, and I feel it falling on my face. I have a feeling. That feeling is experience. How is it related to what's going on physically? How does the physical give rise to it? There's a related problem having to do with free will, and that problem, which I won't really have time to talk about that much, is this. Look, if the fundamental dynamical laws are deterministic, and they say that when the state of the world a long time ago was such and such, then the state of the world in the future is such and such, it's completely determined, what room is there for my decisions to make any difference to what happens? These are very difficult and interesting problems. And philosophers in my tradition bang their heads against the wall all the time trying to answer this. Well, I've worked on both of them and I have things to say about both of them. I won't get to say that much today about them, but I'll say a little bit. Okay. So, so these are the problems. I just mentioned them. Won't go over them again. No reason to. Okay. But one thought that people had in the 20th century is, look, classical physics, classical mechanics is just wrong. We discovered towards the end of the 19th, beginning of the 20th century that classical mechanics, Newtonian mechanics, just couldn't account for the structure of atoms and the relationship between light and matter. And a new physics called quantum mechanics developed to replace it. And quantum mechanics is strange and interesting and mysterious. I don't know how many people in my audience have studied quantum mechanics, but I know there are very important Persian physicists who write on quantum mechanics, and I assume that some of you have learned about it, and maybe some of you are actually in the audience. Some people who've worked on it are in the audience. I don't know. Anyway, it's a very interesting subject and definitely worth reading about. I'll just mention to you, because I'm a teacher, I can't help it. I have to teach and tell people things. There's a book I read recently about the history of quantum mechanics, and I think it's a great read that you probably can get a hold of there. It's in English, it's cheap. It's by a man named Adam Becker, called What is Real? And it's definitely worth just reading. It's easy to read, nothing technical about it, but it's about the history of the subject, and it's fascinating about the interactions between the inventors of quantum mechanics, Bohr and Einstein and Heisenberg and Schrodinger. And there's a story about that Einstein was an old fogey and he kept objecting to quantum mechanics, even though he was one of the inventors, and that Bohr showed him that he was wrong. And this is just completely wrong. Einstein was really the genius who saw that there were big, deep problems with quantum mechanics. And read the book; you'll see a lot in it. If I've done nothing more than tell you about this book, then I've done a good thing in this little talk. Okay, better get on a little bit. Okay, so quantum mechanics looks like it's going to be the complete theory of the world, at least as far as the world is concerned, until we get to very high energies or very strong gravitational fields. Because quantum mechanics and Einstein's other theory, general relativity, have not quite been figured out how to fit them together exactly right. But even though no one's figured that out quite yet, whatever the subsequent theory will be, it will agree with quantum mechanics as far as anything in our ordinary physical world is concerned. So quantum mechanics describes all physical processes. Now, why does my next slide come up? Here we go. Good. Okay, so here are some of the main features of quantum mechanics. To just remind you, I hope these make some sense to you. One is that where in classical mechanics, you describe a system by saying, here's exactly where the particles are. Here's exactly how they're moving. Here's what the field values are. Quantum mechanics is not like that. Quantum mechanics describes a system by saying what its quantum mechanical state is. And the quantum mechanical state of a system is a superposition of ordinary quantities as we think about them. So an ordinary particle might not be, in quantum mechanics, might not be said to be located in Tehran or located in New York, but located in a superposition of being in Tehran and in New York. Now, when you hear that at first, that strikes you as very strange. What in the world could that mean? But quantum mechanics describes things like that. And here's what it means. When quantum mechanics says that what the system is, that does give you information about what would happen if you were to make a measurement to find out where the particle is. And if it's in that state of being in a superposition in these two places, if you were to measure to find out whether it's in Tehran or in New York, you would always find out that it's in one place or the other. What quantum mechanics says is that when it's in that state, it'll tell you what the probabilities are of you finding it out that it's in one place in New York or in the other place, Tehran, depending on what the exact state is. Also, these quantum mechanical states can be what's called entangled. So they can be particles or even bigger objects, which are such that their states are entangled so that when you make a measurement on one and find out where it is, that immediately determines where the other particle or object is or what it's doing, even if they're very far apart from each other. So quantum mechanics has this feature where everything in the universe is connected with each other in this funny way. When people see that, and incidentally, the person who noticed this the first actually was Albert Einstein. When people see that, they get the feeling that there's something strange, mysterious, and mystical about quantum mechanics, because it says that everything in the universe is interconnected with everything else. I'm not sure that really is connected with anything in Eastern mysticism, but many people have claimed that it is. I'm not going to get into that any further, but it's a very interesting feature. And if you hadn't heard about it before, you don't know about it, you should read about it and find out about it. It's very interesting. It really is the case. The Nobel Prize in Physics was awarded last year. I think it was the last Nobel Prize to some experimentalist who actually did experiments who demonstrated that this really is the case. This kind of entanglement really exists. It's not my top of my talk, real topic of my talk, so I'm not going to go into it anymore. So here are some of the main features of quantum mechanics. The main idea is that quantum mechanical states are superpositions. The superpositions can involve entangled states, but when you actually make measurements on systems, you find that the systems are in ordinary states of what you've just measured. That's what quantum mechanics, standard quantum mechanics says. However, the way I just described it, there's a relationship between a, a, a measurement and the description of quantum mechanics. The idea of measurement shows up in quantum mechanics, and that's strange and that's very peculiar. Let's move on a little bit. I better get going a little bit faster. Okay, I think I've said pretty much all of this stuff. Oops. I don't know why I'm doing this. I think we can skip this slide. Okay, it's superpositions that we just talked about. Okay. One of the interesting things that sometimes people hear about quantum mechanics is Heisenberg's uncertainty principle. That really is, I've already really explained that when I told you what a superposition is. You're often told that in quantum mechanics, a particle like an electron or an atom, but the same is basically true for even bigger particles, but in a sort of special way I'll describe in a minute. That a particle like an electron, its typical state doesn't assign it a position, doesn't say where the electron is, quantum mechanical state, and it doesn't say how it's moving. It just says that when you make a measurement of it, you'll find it in some position when you make the measurement, or if you make a measurement of its velocity, you'll find it have some velocity when you measure its velocity. But you could never measure both its position and velocity at the same time. And the quantum mechanical state will just tell you what the probability is that you'll get a certain value for its position, and the probability you'll get a certain value for its momentum. So it gives the impression that the particle doesn't really have, until you make a measurement, doesn't really have a location. It only gets to have a location. It doesn't really have a velocity until you actually make the measurement. This creates the feeling or the idea, and it was quite widely held by the inventors of quantum mechanics, in particular by Heisenberg and von Neumann and Wigner, that measurement is really central and important to quantum mechanics. And that's going to be very important to the rest of my story. Okay. I'm not going to, oops, I want to get that I want to go to the next slide. I don't want to make it bigger. I want to go, how do I get the next slide? There we go. Okay, and to the next slide because we're not going to have time to really get into
Yeah,
this.
Barry, tell me whenever you want to skip the slide.
Okay, next slide. Go to the next slide.
Okay.
I'm sorry that I'm so inept at this.
No.
Okay. I want to, now here's something I just want to write down so you look at it. Those of you who know quantum mechanics, this is very familiar. Those who don't, this is just going to look like mathematical, gobbledygook. But there's a certain law. There were two of the inventors of quantum mechanics were Einstein and Schrodinger, two of the inventors. On the one hand, Bohr and Heisenberg and Pauli on the other hand, and they had very different attitudes to how to think about quantum mechanics. Einstein and Schrodinger, from the very beginning, knew that there was something strange about quantum mechanics because of the way entanglement and measurement appeared in the theory. The other thinkers, Pauli, Heisenberg, and Bohr, they kind of wanted to tell a story which made measurement and observation part of physics in some way. Einstein and Schrodinger didn't want that. But Schrodinger found the right law to describe how the quantum mechanical state of a system evolves over time. And I wrote down the law here. I'm not going to really explain it because it's physics, but it's a deterministic law. Just like Newtonian mechanics, the fundamental dynamical law of quantum mechanics is deterministic. It's not probabilistic. It says how the state of a system evolves deterministically over time. The way probabilities enter into quantum mechanics, that occurs, next slide, can you get the next slide? That occurs only when measurements are made. Now, if you were to describe measurements as ordinary physical interactions, in according with Schrodinger's law, then what Schrodinger's law says is something very strange. Next slide. Go to the next slide now. Okay, I go to the next slide. I can describe it with a picture. Okay, that's something everybody has heard about. What Schrodinger's law says is that when you make a measurement of a system, like suppose you had a cat. Okay, suppose you had a particle, an electron, and the electron was in a superposition of being in two places. Let's say in I could say New York and Tehran, but those are far apart. Suppose that's in in Brooklyn or Manhattan, and you're measuring to find out whether it's in Brooklyn or Manhattan. Well, what Schrodinger's law says that when you made the measurement apparatus would not really say that it's in Brooklyn or say it's in Manhattan. But what happened is that the measurement apparatus would itself go into the superposition of recording that it's in Brooklyn and recording that it's in Manhattan. And if the measurement apparatus was itself a cat, so that the cat ended up being alive if the electron was in Manhattan, dead if it was in Brooklyn. Sorry to say this about cats because I love cats, but Schrodinger's example. But then what Schrodinger's law says is that the whole system would evolve into a superposition of the cat being alive and being dead. But of course, we don't even know what it would mean for a cat to be in a superposition of being alive and dead. So something screwy is going on here. And what Bohr and Heisenberg said, or what Heisenberg said and Wigner said, is that, well, when you're making a measurement, Schrodinger's law stops. It no longer holds, and a new law holds. The new law is called the collapse of the wave function. It's a law that holds only when measurements are being made. Next slide. So there's a rule that says in standard textbook quantum mechanics that when a measurement is made, the system no longer evolves in accordance with Schrodinger's law, but evolves by this probabilistic law that says with a certain probability, you get one outcome or you get the other outcome. Okay, next slide. We'll get back to consciousness with the next slide, I think. So this means, or the two slides, that when the collapse of the wave function depends on there being a measurement. And when is a measurement made? Next slide. Next one. Well, this is the measurement problem. When does a measurement actually made? And one idea is that measurements are only made when a conscious observer becomes aware of the outcome of the measurement. That's how consciousness gets into quantum mechanics. Next slide. Next one. So it's observation that collapses the wave function. Here's a famous picture that I believe Wigner himself, no, Wheeler, the famous physicist Wheeler drew. And it shows the idea that somehow it's the observer looking at a system that causes that system to collapse. So when people saw this, they thought, consciousness has been brought back into physics. We have to have consciousness added to the physical world to make physics even work. That's the idea. Now, I think this idea is really bad, but it was an idea that was held by very famous physicists, and you can even find people who hold it now. This idea is that it's consciousness itself causes the collapse of the wave function. Now, how does it do this? How does something non-physical cause something to change in the physical world? Nobody could really say. They just added this as an assumption. Go on. So go on to the next slide. We go on to the next one. I think what I hope what I'm saying is making some sense to you. So this is the proposal, and some people have it, but just stop and look at it for a second. It says physical states that are associated with consciousness, they themselves cannot be components of superpositions. They're special. They're not physical. When a system would evolve by Schrodinger's law into a superposition that includes components corresponding to conscious states, it evolves to states that would result from the collapse into one component of the superposition in accordance with the usual Born rule that says it collapse into this state or into the collapse into the other state. So consciousness observing, when you actually look, when the cat, suppose the cats are conscious, which I believe they are, when the cat looks at the electron, rather than going into a superposition, it causes the electron to go into a particular state of being located in either Brooklyn or Manhattan. That's a very interesting idea. Next slide. Go to the next slide now. Okay, so this is called the consciousness collapse account. I basically described it. It's the cat or you, by interacting with things in the physical world, cause the quantum mechanical state of the world to change. If there was no consciousness, the world would just evolve in accordance with Schrodinger's law, and everything would be in a superpositions of various kinds of states all the time. But when consciousness comes into existence, that causes the physical world to change in this different way. Next slide. Next one. Okay, so this view is frankly dualist. So many philosophical views before the modern era, at least in European philosophy, were called dualist. That is to say that, or at least dualist, to say there are at least two kinds of fundamental stuff in the universe, mental stuff and physical stuff. Descartes' view was like that too. But as I said earlier, given the development of science, it's difficult to be a dualist because it looks like every physical change that occurs has a physical explanation for why it changed the way it did. So what room is there for non-physical stuff to make any difference in the physical world? But now that quantum mechanics developed, it looked like maybe you needed consciousness in order to make changes in the physical world. Okay, that was the whole idea of why quantum mechanics and consciousness might be closely related to each other. If I've gotten that idea across to why that idea came up, that's great. I'm glad I've explained something, but I think this idea is terrible. I think it's a bad idea, but it's a very widespread idea in parts of physics, especially up to the 1950s. I think it's less widespread now. Next slide. We're getting close to the end. Okay. So back to the hard problem. How does consciousness fit into the physical world? Well, maybe the answer is that it doesn't, because there's consciousness is something fundamental and basic and part of reality, and it's needed by physics itself. And that's an idea that's sometimes had by people who had the view that I just explained. Okay. And so this would be a way of responding to the hard problem. And this philosopher, Dave Chalmers, my friend and colleague, lives down the block from me, actually. He kind of likes this idea a bit. I'm not sure he goes so far as to hold this about quantum mechanics, but he does think that conscious states are over and above physical states. Okay, next slide. I recommend you looking at his book if you have time to do that. So this idea, the consciousness quantum mechanics connection, the consciousness causes collapses, has many attractions. And I've listed a bunch of them here. I'm going to catch my breath while I let you read them for a second, because we're almost at the end. And then I'll give you my conclusion to all of this. Just read that for 1 second. These are the attractions of this idea. So I'm building up the idea only to throw a lot of water on it, because I'm going to say it's a terrible idea. Okay, so let's go to the next slide. I hope you've had time to read this one. So I'm not persuaded by any of this. The reason I'm not persuaded is, first of all, we have no idea how consciousness could cause the collapse. There's no theory about that. We're not even sure what conscious states are. When are there conscious states? How conscious do you have to be? I mean, when I woke up this morning, I was a little bit conscious when I woke up. My alarm rang to wake me up on time. Was that enough for me to collapse any states? I don't know. What does it take to collapse? And which states get collapsed? There's no one ever really developed a real precise theory of any of this stuff. It was just an idea that floated around. So I don't think it's really right. And it's very puzzling how a small change in what's going on in a mind can make such a big change in the physical world. In fact, according to this theory, as the galaxies evolve, they're evolving according to quantum mechanics. And so the states of the galaxies are in superpositions of where they're located until some astronomer turns his galaxy and makes a measurement or observation on the galaxy. And all of a sudden that will make those galaxies turn into become into determinate positions. That idea just seems crazy. So I think this is really, really bad idea. Now, some people who thought this a bad idea had a couple of responses that I'm not really going to have time to do more than mention to you, and some of you may have heard of, but you might want to look at later. One response to this is to say, no, maybe this collapse idea was really, really bad. Maybe the world just evolves in accordance with Schrodinger's law all the time, and maybe things really go into superpositions all the time. So really, cats really are in superpositions. And maybe your body is in a superposition. You think you're in Tehran now, and I think I'm in New York. But actually, our bodies are in superpositions located all over the universe. Then you might say, that's crazy. How can that be? Well, the people who like this view, it's called the many worlds interpretation of quantum mechanics, they have a ways of defending this view. I've written about this. Me and a friend of mine named David Albert. He was my friend. He was my friend who went to Tehran 25 years ago and told me what a great time he had there, incidentally. Um, he and I wrote a paper trying to show what's wrong with the many worlds in kind of quantum mechanics by developing something we call the many minds interpretation of quantum mechanics, which said, well, you can make sense of this, but only if you add minds to the story, but not in the way the consciousness collapse account does, but in a different way, which involves just having minds floating along with the wave function, just that there would be a lot of different minds, with the minds experiencing different experiences corresponding to the big superposition, so that if you had a superposition of being in New York and in Tehran, there'd be a mind experiencing being in New York and another mind experiencing being in Tehran. You could read the paper about this called The Many Minds Interpretation of Quantum Mechanics, a couple of papers by David Albert and me. Again, I can send you references to it. Actually, they were published a long time ago now. We meant this papers, incidentally, to be kind of a joke to show what's wrong with the many worlds interpretation. But I learned something very important when you're a philosopher. If you write a paper that's meant to be a joke, not to be taken seriously, you have to say in the paper, don't take this paper seriously. It's not meant to be a serious proposal. It's meant to show what's wrong with another proposal, because there were people who thought we were being serious, but it was meant just to show what's wrong with many worlds. But there are a lot of physicists who take the many worlds interpretation quite seriously now. Very important physicists, really. In fact, it's a common view in cosmology among cosmologists, but they don't really think hard about what their theory really commits them to, I think. Okay, so I don't think this approach is right. So let me say what I think you should think about consciousness, and then I'm going to end, because I've been going on way too long, and you've been very patient. So thank you. Next slide. Next slide. Okay. Okay. There are some other ways of making sense of quantum mechanics. Again, I'm not going to tell you about that, but you can read about them in if you send me, I can give you references. But this book I told you about by Adam Becker called "What Is Real," he has short descriptions of them. There was a physicist named David Bohm. He also thought that there were very mystical connections between quantum mechanics and spirituality, but not in the way I was talking about before. But he also had a very I don't buy that part of his views, but he had a very good way of understanding quantum mechanics, in which there's Schrodinger's law is the main dynamical law, but he avoids these many worlds by doing something else. He has a good way of understanding quantum mechanics. And there are other ways of understanding quantum mechanics. I've listed some at the bottom here. And in these views, consciousness plays no special role, except, like I said, in Everett's many worlds interpretation. In order to really, really make sense of it, you got to add minds, I think, to make good sense. Again, I'm not going to say anything more about them. Next slide. Next slide, because I'm not going to have time to talk about this either. Next slide. Forget about free will. And anyway, okay. Here's an idea which has sometimes been around, which I think is intriguing and interesting. It's been suggested by the two famous physicists. One I'm sure you've heard of, named Richard Feynman. Another guy who's still alive at Stanford, named Leonard Susskind. He has lectures that are online that are very interesting to look at. He's old. He's even older than me, but he's very interesting to look at. They think that, well, maybe quantum mechanics is mysterious because human beings are just not smart enough to understand quantum mechanics. Why aren't we smart enough? Well, because human beings evolved. We didn't evolve to understand quantum mechanics. We evolved, to produce more human beings. Like we evolved in the same way that other animals evolved. And so while we have our brains enable us to get along and get food and do other things, our brains also did a lot of things like create wars and things like that. So to put good and bad things, and enable us to do some things like learn how to do mathematics, but not well enough and not well enough to solve a lot of problems in the world. And that's an interesting idea. This idea has also been held by some philosophers. The famous linguist Noam Chomsky has this idea, and a former colleague of mine named Colin McGinn has this idea. They just think that some philosophy problems are just too hard for human beings. That's an interesting idea, worth thinking about. Next slide is going to be my last slide. So I am not so pessimistic. I do want to throw a lot of cold water on the idea that quantum mechanics and consciousness are especially connected. I don't think they are. I don't think quantum mechanics needs consciousness, and I don't think there's anything about quantum mechanics that can shed any special light on the nature of consciousness. But I do think there are some ideas that have been developing recently, and I just want to mention them to you if anybody wants to look them up. One of them was thought up by a former colleague of mine, now deceased, and the other one, the main developer of, is a colleague of mine who I also happen to be married to, named Katalin Balog. She's my wife. She was also invited to give a talk at this conference, but she's too busy doing other stuff, so she didn't do it. But she writes on what's called the phenomenal concept strategy, and it's the idea that explains why we cannot understand consciousness as being something physical, not because it isn't physical, and not because we're not smart enough, but because with the way we access our own conscious states, the way our brains work to give us contact to our conscious states, uh, have us conceive of consciousness in ways that just don't allow those concepts to be connected to physical concepts. This is a very interesting and intriguing idea. So I just recommend it if you're interested in it to look into it a little bit under the names Brian Loewer and Katalin Balog. There are other people too. In fact, I noticed that some people at this conference, I don't know the person, but it's an Iranian philosopher, is giving a talk on the phenomenal concept strategy. I hope I'm able to listen to it later. I'm really interested to hear what it is, and maybe he can contact me and we can interact about it. And then I didn't say anything about free will, but I'm very interested in that. And I do think there are ideas about how to connect up physics and free will, connected up with how to connect up ideas in physics, not having to do with quantum mechanics especially, but other parts of physics involving probabilities. So I do think that philosophy there are promising avenues for saying things about how to fit the mind into the physical world. I myself would I'm a physicalist. I do think there's going to be a complete physical description, a theory of the whole world. I do think already there's a physical description of the world of medium-sized objects that include physical bodies and even small objects like atoms and big objects like stars. I just don't think that we have the complete theory, which also holds for black holes and very, very small quantum mechanical states. Okay, but I don't think we have a good account of how all of this can give rise to mental phenomena, particularly give rise to consciousness, to intentional phenomena like beliefs, preferences, desires, decisions, and to free will. But I do think there are promising avenues, and I tried to just tell you about a couple of them right now, and I'm just going to end with that. And I'm sorry I took too long and was so all over the map, but thank you very much for paying attention at any rate, if you did. Okay,
Thank you so
the end.
very lovely presentation, informative, insightful. I personally enjoyed it from the start to the end. Thank you so much. We have 30 minutes, Barry, for Q&A, for questions and answers. عزیزان اگر میخوان سوال بپرسن میتوانن به انگلیسی بگن، اگرم مایل نیستن به انگلیسی بگم میتونن به فارسی بگم براشون ترجمه کنم. در تکست باکس هم میتونن اول با سوالهای در واقع شنیداری هستیم، بعد به سوالهای تکست باکس میرسیم. آقای حسامی میکروفونشون رو بس میکنم. آقای حسامی بفرمایید، میکروفونتون وصله.
سلام. خیلی متشکرم از شما پروفسور. I highly thank Mr. Professor for his presentation, and I also thank the organizers for organizing this, I believe, unprecedented conference held in Iran internationally on philosophy of mind. Of course, I study philosophy, so I have only a very elementary acquaintance with quantum physics. I have one question, and then I also have a question, which is a form of recommendation. When they talk about in quantum physics about the impact of the observer on the measurement of the quantum field, is this really a hypothesis or really established beyond doubt? I recall Professor said that there was a Nobel Prize given to someone recently who actually proved that human mind directly influences the outcome of the measurement.
No, that's not what I said.
Oh, so I misunderstood that part. So, I mean, is this the observer effect? Is this a hypothesis or proven empirically? This is my first question.
Good question. Okay. All right. So it's a hypothesis, and the reason the hypothesis was cooked up, and I just went over too much territory too quickly, so that's why it got a little bit compressed. The idea was this: when people developed quantum mechanics, they realized that the fundamental mathematical theory had the funny consequence that if the theory just applied in ordinary measurements, you wouldn't get outcomes to measurements. You'd end up with cats and superpositions. And so they had to change the theory, and they made the hypothesis that when measurements were made, the wave function collapsed. It didn't develop in the normal way. So it was a hypothesis. But it's never been tested, except insofar as, of course, when anybody does make a measurement, you do find an outcome. You never find yourself in a superposition. We don't even know what that would mean, to find yourself in a superposition. So in that sense, it's tested. On the other hand, there are ways in which you can say that you're in a superposition, but for certain reasons, you don't really realize that you're in a superposition. That's what the many worlds interpretation says. So it's not clear that that's what that it really is tested just by finding yourself by experiencing a precise a definite outcome. The Nobel Prize was awarded for discovering that these entanglements
Oh,
really
entanglements.
exist. That's what really exists. And that's connected to something called Bell's theorem. I didn't really get on to explain that. But the book, since you're a philosopher and you might want to, you want to find out a little bit more about what we're talking about,
Yes, I will.
I very strongly recommend this book because, like I said, it's not technical and it's easy to read, by Adam Becker, Becker. I don't know how easy it is to get books wherever you are, but Amazon sells it for $2, I think. It's a paperback. I don't know how you can get it, but I'm sure you can get it through libraries and stuff like that. It's called What is Real by Adam Becker. I'm not telling you that because he's like a friend and I make money off of it. I know the guy. I met him, but I don't really know him very well. And I don't know if he even makes any money off it, but it's a really good book. I was very impressed by the book when I read it. What is Real?
um, So thank you. Now that this is a hypothesis, I want to make a last point, and that is there are studies. I'm not sure whether you approve of those kind of studies or not, but these are parapsychological studies called psychokinesis, telekinesis.
Right.
This is the
right.
study of evidence or a study of the possibility of human mind influencing objects, whether living objects or non-living objects. And because I have recently started studying into parapsychological literature, and I found that there have been substantial literature reporting these observations, many kinds of observations, many kind of tests actually, that appear to have proven empirically that minds can influence distant living organisms, and there's a vast literature on that. Since I got introduced into this literature, I was always wondering why this is not taken seriously by the mainstream philosophers of mind, because these findings have profound implications, and
They do.
I can introduce a source on that, and I believe this was his name is William Baker, William Broad, and he has written reviews and meta-analysis of literature on biopsychokinesis. That is the influence of mind on living organisms.
Okay, so can I say 1 or 2 words about this?
Sure.
Okay. So first of all, I'm a kind of open-minded guy. I'm willing to entertain anything. But my belief about this, can I be really opinionated and tell you what I really think? I think it's crap. Okay.
Sure. That's
Okay.
I believe a standard response I have.
Okay. However,
But I can introduce you a group of actually neuroscientists from USA. I don't know if you have heard about them, who are very interested in this, and they have written actually a book called Irreducible Mind, and I have been translating that book. I'm not sure if you have heard about them. The lead author is William.
Do you have
F.
my
Kelly.
email? Do you have my email? Send me an email with information. I'm very interested to see.
Sure, I will.
One thing I want to say is I'm absolutely sure that minds can influence bodies. Completely sure about that. The reason I'm sure about that is I'm now influencing my hand. I'm raising it up.
Yeah.
So I'm sure my mind can influence body. I do not think my mind now can make my glasses just move by wanting my glasses to move over there. I do think I can pick my glasses up and put them on my eyes, but I don't think I can make them move. But maybe I'm wrong. And maybe these parapsychologists have shown this can happen. The trouble with it is it'd be hard to fit in with everything else we know. And one thing we want is we want our different views that we know about the world to all hang together.
Sure.
Maybe, but I don't mean it can't be. There've been times in the history of science when there were conflicts very famous ones. We don't have really time for me to go on about it right now, but very famous ones where let me just give one example. The theory of natural selection, when it was first thought up by Darwin, didn't fit in with what was known from geology at the time. And so people rejected natural selection because of what they knew of geology. Well, they were wrong. They had to really think things through more carefully and work things out better. And maybe that's going to be the case here too. So maybe I'm wrong, and maybe I'm wrong to say that this is crap. But I think that there's so much going to be so hard to see how it is than merely something going on in someone's mind. We don't have any idea what kind of fields or physical changes in the electromagnetic fields or other kinds of fields there are, or what new kinds of fields might be introduced. Nobody has theories of them or anything like that. Can be involved. But maybe these people have been developing that, and if they do, more power to them. Let's see what happens.
Yeah. Yes, in fact, I appreciate that this kind of evidence have raises deeper questions, and for those questions, they still need to keep looking for answers because they raise more difficult questions. How you systematize all the evidence into a greater picture of reality and greater picture of the world, and they have been follow-up theoretical studies on these parapsychological findings to speculate about this fuller significance of this data. And I can email them to you. There has been substantial work done in this direction, and most of that work, I mean, nearly the entirety of that work is ignored because it's not part of the standard academic curriculum. So most philosophers and psychologists just they do not acquaint themselves, just assume that these are crap. And
that's the nature of research. That because no one can do everything at once, and you got to figure out which is the best thing to follow up. A lot of the stuff that I'm really interested in, many physicists. When I go talk to physicists in my university, most of them want me to go away because I'm interested in problems which they just find annoying because they want to get on with doing their experiments. They don't want to think about. I mean, for example, a problem that I'm really interested in, really interested in, is what is probability? What is the nature of probability? Most researchers can work with probability without really understanding what it is. They don't have to really think about it, about its nature, in order to work with it. And so they don't want to think about it. So they want to ignore my problems about it. And I understand why they want to do it. But you do what's interesting to you, and you see what happens. Who knows what the future will be? Maybe 1,000 years from now, parapsychology will rule the roost, and the things that I think now will be said to be crap. I have no idea. But I won't be around 1,000 years from now. Okay. But thanks for the comment. That was a really good comment and interesting remark.
Thank you.
Send me an email. We can exchange emails after a while.
Sure, I will. Thank you. And there are other people having questions, so I just end up. Thank you.
Sure, thank you.
ممنون از آقای حسامی. Barry, I'm going to read you a question from the text box because I don't see anybody raising their hands. Mohammed has asked that, how can we trust quantum mechanics and call it science while denying replaceability? I think we can consider just a way of justification of phenomena and not a fact. And that was his question.
I'm not sure I understand the question. The question is, how can we trust quantum mechanics? And because of what? I didn't understand.
Call it science while denying that replaceability, while denying its replaceability.
Right, but denying, what are we denying if we're trusting science?
That you can replicate the replication of science.
But scientific experiments are replicable.
But that's he said. You maybe misunderstand it. That he said that quantum mechanics are not. You can't replicate quantum mechanics tests. That's maybe why he's.
No. Of course you can. You can. The actual experiments that support quantum mechanics have been repeated hundreds of thousands of times. So the particular experiments that are cited to support quantum mechanical theories have been done many, many, many times. You can read about them in many, many textbooks. What's puzzling about quantum mechanics is the theory that's been developed, when you really look at it, is very, very puzzling. And it doesn't really make sense until you really interpret it and fill it out. This is what Einstein noticed about it at the very beginning. And so the big problem is to take there's a mathematical theory of quantum mechanics. It can be used to give the results of experiments. That's perfectly fine when giving the results of experiments. Those experiments are replicated over and over again. The mathematical theory works out right. But then you ask, what is that mathematical theory saying about what the world is like? You look at that and you scratch your head and you say, what does that really say the world is like? It says things like that the state of a system gets into a superposition until a measurement is made. And we don't really understand what that could be and how that's supposed to work, and how states go from being in a superposition to not being in a superposition. That's the part that's puzzling. So the problem with quantum mechanics is really what might be thought of as an interpretational or philosophical problem. It's not really a scientific problem. As far as science is concerned, quantum mechanics is doing just great. Scientists know how to use quantum mechanics to make predictions perfectly. And they not only can make predictions, they can use it to build things like transistors. They can build things like atom bombs, unfortunately, and worse things than that. But they also use it to build, MRI machines. So the MRI machine that's used to diagnose cancer, that's based on quantum mechanical mathematics. That works fine. But what the world is like that's being described at its fundamental level by these theories, that's what's puzzling. That's why philosophers come into this story. The philosophers are trying to understand what quantum mechanics is saying the world is really like. Maybe I should have been really clearer about this. There are so many issues to talk about when you talk about philosophy of science. One way to understand the whole point of science, there are two ways to understand science. Science is just a tool to help us get better food, better machines, better bombs. That's one way to understand science. Another way to understand science is to tell us what the world is really, really like. I want science to do the second. I like it to do the first when it gets good things too, but it's the second, telling us what the world is really like. Science has told us how the planets really move, that they really move around the sun, and the Earth moves around the sun, and they tell us the orbits in which they move, and this enables us to make predictions and to have calendars. So it has consequences that we can use, but it also enables us to understand what's really going on. And the problem with quantum mechanics is that it developed in such a way as a great predictive tool and a great tool to build things, but not as a good way of understanding what the world is really like. So the real struggle is to interpret it, to give an account of what the world is really like. And one of the ideas is this idea that connects up consciousness with quantum mechanics. And that idea I said I don't like. I don't think that's very good. But that's one way. Another way is some of these other suggestions I made. Is that helpful to the person who asked the question?
I'm pretty sure he says that maybe it works functionally, not ontologically. So
Yes, that's a good way to put it. Those are fancier words than I use, ontological and functional. I would use the words realist and instrumentalist. So some people think of science as just an instrument. That's just for making predictions and for building things. Some people think it realist for really describing what the world is like. And if I wax really philosophical, be really philosophical about it, in some ways science has replaced theology. Theology was, before the science really developed, was supposed to tell us what the world is really like. And maybe that's right. And maybe it should have just stayed like that. But one of the things that happened is that science started playing a role in telling us what the world is really like. And that kind of replaced theology or tried to fit together with theology.
خانم بهمنپور میکروفون شما رو بس کردم باش میریم به سوالای باقی مانده تکست باک آقای رئوفی نیست. اول خانم بهمنپور بفرمایید.
مرسی متشکرم سلام. Thank you very much for that very interesting talk. My question is regarding the difference between mental states and conscious states. Do you consider that there to be a difference between the two when we're talking about consciousness and quantum mechanics?
Mm-hmm. So I think conscious states are mental states, but they're not exactly the same thing. So some mental states are unconscious. And when we talk about mental states, philosophers in my sort divide them up into really two big groups. Experiential states, like what have to do with how things feel, like, you know, I now feel the sun on my arm. That's a certain feeling. Then there are states that have to do with what you might call content. I believe that the sun has arisen. I want to eat breakfast. These are states with content. Our language has sentences in it or words in it which have meaning. Meaning expresses content. So if I believe that it's raining, I could also say what I believe by saying it's raining. These also involve mentality. Of course, the sentences themselves aren't mentality, but they have meaning because of their relationship to mental states. So is this in the ballpark of what you have in mind, what you're talking about?
Yes, exactly. And I'd like to know if in the hypothesis of collapse caused by consciousness, mental states are also accounted for when we talk about consciousness.
You know, the physicists who thought this up were not so sophisticated as you. So they didn't make this distinction. I think that probably they would want to say that the conscious states are caused by states which are both, because often experiential states both have content and experiential. In fact, typically they do. When I experience the sun on my arm, it has the content. It's an experience with a feeling, but also has the content that, you know, of a certain feeling on my arm. So they're not so separable. And there are some philosophers who think that experiential states can be explained entirely in terms of content states.
Right.
And others, I mean, we're not deep into philosophy of mind. And it sounds like that's what you are. You're a philosopher of mind, right?
Yes, I'm hoping to be.
So you know a lot about this. I know a little bit about it. My wife knows much more about it than I do. You know, it's what to say. One of the things I notice, the philosophers of science, like I am, often don't make the same kinds of distinctions that philosophers of mind do, and vice versa. And they could, it would be better for them to talk to each other more.
Yeah.
That's why I married a philosopher of mind. But we end up talking about how to raise our kid more than talking about philosophy. So.
Thank you for that. Can I ask you another question? Is that
Sure.
Okay. So when you said that conscious states cannot be in a superposition and always determinate, can you elaborate a bit more on that? Do you have any evidence for that? Is it only experiential, what you can experience?
Yes. Yeah. So here's what I meant by that. If conscious states really are physical states, then they can be in superposition, and quantum mechanics is right, then they can be in superpositions. But they never seem to us to be in superpositions. That's what's so puzzling. How can we square those two things? One way to square them is to say that conscious states just aren't physical. And that's what these consciousness collapse people are saying. Because they say if they're not physical, they aren't in superpositions. Another way, and that's what the many minds view says. Another way is to try to somehow explain it as just a kind of illusion that we just have somehow our brains are so made up and the physics works in just such a way that we just never can experience being in a superposition. And we always mistake that we're making a mistake that we're not in a superposition. And there've been attempts to try to come up with accounts like that.
Mhm.
I can't really, I don't really believe any such account. I can tell you someone to read who's a physicist who tries to do this, but there are other people too. So I'm not giving you necessarily the best person, but there's somebody you might have heard about because he's a very popular science writer. He's a very good physicist, but a science writer named Sean Carroll. Do you know that
Yes.
name?
Yes, of course. Mhm.
Okay, so he's written a book on quantum mechanics. He's written a number of books. He's very, very good. He's also a friend and written a very good book on quantum mechanics. He's a person who likes this many worlds interpretation of quantum mechanics. I think it's wrong, but I'm not going to tell you why I think it's wrong right now. But he tries to develop the view that I just explained, that it's kind of an illusion. He thinks that actually our bodies are physical, our brains are physical, our mental states are really physical, they're really in superpositions. But because of the structure of brains and physics, we always are mistaken and never can notice that we're in superpositions.
Hmm.
Does that make any sense, at least?
It does. I'm just wondering if you consider mental states to be part of a conscious states that
Yes.
we're talking about, then
Yeah,
you can say that,
yes, I think so.
Then you can say that perhaps a state of doubt is a superposition when you have
Yes.
two opposing
So right
ideas.
now, you think you're talking to me, right now, but in
Mhm.
fact, if quantum mechanics is right, there's a mental state associated with your body. Your body is in a superposition, and
Hmm.
I don't even want to say what kind of superposition is because it's going to be enormously big, involving entanglement with an immense number of things,
Mhm.
and some of those things will be associated with mental states of all sorts of things. Some of them will actually think you're talking, to I don't know, to all sorts of other people right now, and not to people,
I
and
see.
so on. But you just can't notice it. Okay,
Right.
and
I
that
see.
may seem so bizarre that you may think I'm just out of my mind to even say that. So read Sean Carroll's book to see whether
Mhm.
you can make any sense of it. I don't think you can make sense of it. That would be the idea. My own view is really what's going on is you're not in a superposition, you're in a determinate mental state. Quantum mechanics is right. Okay, let me tell you my idea. I never expressed it. My
Mhm.
idea follows this physicist David Bohm. There's more to the world than quantum mechanical state. There's also other physical phenomena in the world. And when you take both of these together, they're sufficient to put you in a determinate mental state and to put the cat in a determinate position and to put the galaxies in a determinate position. So although the quantum mechanical state is a superposition, there's more to the world which makes the world fundamentally in a determinate state.
Mhm.
Okay, now you really, I can't explain this in 2 seconds, but that's the basic idea.
But I very much agree with you, and that was very clear. Thank you.
Oh, good. So look at this book by Adam Becker. He has a good account of Bohm's
Mhm.
theory in it. Not a technical account. And if you send me an email, I can tell you where to look at it. Or I've written much about it too, and people smarter than me have written about it.
Mhm. So thank you so much. That was really interesting. Thank you.
Okay, thank you. Send me an email. I'd like to know who you are.
Will do, definitely. Thanks.
Okay.
Before we go to our last question from Mr. Raufi, just wanted to say that there's actually a Persian translation of the Adam Becker book. ترجمه فارسی کتاب رو دوستان تو باکس آوردن.
Really? That is
Yeah,
great.
yeah. So
I'm about to publish a book called "What Breathes Fire into the Equations." I don't know if does anybody know where that phrase comes from? What breathes fire into the equations? It comes from Stephen Hawking, but he just says it. I use it as the title of my book. It's coming out in July. I will be so lucky if my book gets translated into Persian. I don't think my book will be popular enough to get translated. I'm lucky enough it's being written in English, but maybe it'll get translated into Persian. That would be fantastic.
That would be lovely. Okay, I'll read you this question out. Do you find this, Mr. Raufi has sent this question. Do you find the following statement true? An individual's movement against the stream of entropy in the universe results in the existence of its consciousness, and meanwhile, it is a result of it.
Can you say that again? I didn't really understand it.
Do you find the following statement true? An individual's movement against the stream of entropy in the universe results in the existence of its consciousness, and meanwhile, it is a result of it.
Against the stream of entropy.
Yeah.
Okay. Oh, that's a great question. I'm not sure I want to say anything more than that, okay? Except this. That's one of my main interests. And my second book is basically about entropy. I don't think anything moves against the stream of entropy. That's one of the most fundamental features of our universe. However, entropy applies to the universe as a whole. Small systems do move against the stream of entropy. So, for example, your body, as you're living now, you're keeping the entropies low. That's how you're able to stay alive. But you only do that by creating a mess around you, by creating entropy increasing around you. So when you breathe, you're taking in oxygen, using energy. You're using energy to decrease the entropy in your body, burning food and decreasing entropy in your body. But you're exhaling into the air warm air, which is increasing the entropy around you. So entropy is increasing in your environment. So some systems can decrease the entropy in themselves only by interacting with their environments and increasing the entropy in their environments. I do think that human beings do that as long as they're alive. When we're dead, we then just continue increasing entropy, I guess, basically. But the universe started out, is another amazing thing about our universe. It started out in a very, very low state of entropy, spectacularly low. Roger Penrose, the physicist, calculated it, and it's a spectacularly small amount of entropy. This physicist I mentioned before, Sean Carroll, wrote a whole great book about this called what's the name of it? From Eternity to Here. It's a really great book about this whole question. And it's about how entropy of the whole universe increases while the entropy of small systems decrease. And the increase in entropy is very much connected to the way we experience time is increasing, and our experience of time is very much connected to the very nature of experience. So all these things are very much interconnected with each other, and it's fascinating subject. So I'm not really answering the question fully because it's just too difficult and interesting a question, but it's a great question. And if the person who asked it may know a lot more about this than I think, maybe more than I know about it. But I suggest to him that he looks at Sean Carroll's book From Eternity to Here to look at the increase in entropy. But he might know all about this already. So
Yeah.
thanks for the question.
Okay. We had really good questions.
We did. I'm amazed because I thought my talk was so incoherent. So
Yeah.
But you guys are smart guys. Yes, good questions.
We're in a very multidisciplinary panel. We got from different disciplines, from philosophy to physics to neuroscience so there's a lot of variation in the people that are participating. So
I'm a multidisciplinary guy.
Yeah.
Before I say goodbye to you all, first of all, let me thank you. Secondly, what happens next? And I can clue into the rest of the conference, right? Just by staying online.
Yeah. Next we'll have Charles Taliaferro, and then after that we'll have Richard Swinburne.
Okay, great. I know Swinburne a little bit, but not super well. But
Yeah.
I'm interested to hear both of them, and just want to get some breakfast. So, okay, can
We
I
would
say
love you to
goodbye
hang
to?
around. We would love you to hang around. I know it's like early in the morning, but like we would love you to hang around.
Okay, I haven't eaten breakfast, so I got to get some breakfast. Okay,
Okay.
okay. Thanks for inviting me, and thanks for the question. And anybody who wants to email me, I'm very interested in being in contact with people from other countries and spreading my ideas and hearing what other people have to say. So bye to everybody.
Thank you very so
Thank,
much. Thank you, Professor Loewer.
okay, thank
It was
you,
an honor
thank you.
having you
Bye.
here.
Okay, thank you. Bye bye.